Hello everyone, this is Teacher Harold, your junior high school mathematics teacher. And in this video, I will discuss the next lesson in Mathematics 9. And this is solving problems involving quadratic equations, particularly the number problems and the rectangular dimensions problems. So in this video, after you watch this, you should be able to translate worded phrase or sentence to mathematical expression or equation, and then solve problems involving quadratic equations. In this material, you need to use the skills you gained in solving quadratic equations using any appropriate method which was tackled in the previous lessons, together with your ability to translate verbal phrases or sentences into mathematical expressions or equations to be able to solve word problems that can be modeled by quadratic equations. For our next slide, expressing worded sentences or phrases to mathematical expressions or equations. So here we have this instruction. So represent and translate. Use a symbol or a variable to represent the unknown quantity, then translate each of the following statements or conditions to mathematical expressions or equations. So in this next slide presentation, there are three given statements or conditions to be translated to mathematical equations or expressions. So the first one is the sum of two numbers is 17 and their product is 60. Second, the difference between two numbers is 6 and their product is 27. And the third one is the sum of two numbers is 14 and the sum of their squares is 100. So let us consider the first item, which is number 1. The sum of two numbers is 17 and their product is 60. So the first thing we need to do is to represent those unknown quantities by a symbol, by symbols. So for our solution, other than x, we can also use other symbols to represent the unknown quantity. So instead of x, what symbol are we going to use? Okay, so we now go to the representation part. So obviously, we use small letter n to represent what? The first number. Okay? Now, since there are two numbers mentioned in this statement, if n is already taken by the first number, now how do we express the second number? That is 17 minus n. For, again, the second number. Why? Why 17 minus n? Simply because the sum of these numbers is 17. Okay? Then, upon representing the two unknowns by these symbols, by this symbol, one is n and the other quantity is in terms of n, we now go to the translation. Now, since the product of these numbers is 60, therefore, first number multiplied by the second number will give us a product of 60. So if we're going to translate it to mathematical equation, it goes like this. First number, which is n, multiplied by the second number, which is quantity 17 minus n, and that is equal to 60. Next, since this is This formulated equation is quadratic. We can change this to standard form. So what do we do? N is to be distributed to each term inside the parentheses. So that will give us 17 times n minus n times n. Okay? We use the distributive law, and that is and this is equated to 60. So simplifying the left side further, so that will give us 17n minus n squared, and that is equal to 60. Okay? So obviously, we are seeing a quadratic equation whose degree is 2. No? So, transposing those two terms on the left to the right, we have 0 equals n squared minus 17n plus 60. Or using the symmetric property, that will give us n squared minus 17n plus 60 equals 0. And at this point, we have just transformed the equation, this formulated equation, to this form, which is now known as the standard form. And from that point, we can solve this equation using factoring, because this quadratic expression is factorable. And what is it? And what is its factored form? It's actually quantity n minus 12 times quantity n minus 5. And applying the zero product property, we equate each factor to 0, and we will have two resulting linear equations in one unknown. One equation is n minus 12 equals 0, and the other equation is n minus 5 equals 0. And we can now solve each of these equations to get the roots. The first root is 12, and the other root is 5. Okay? Now, so if the first number here is 12, how do we find for the value of the second number? Yeah. So therefore, for the second number, we will have 17 minus n, and we know that n is 12, so you plug in 12 to this symbol, and so we have 17 minus 12 will give us 5. Now, if we consider the first number equal to 5, therefore, again using the same expression, which is the representation of the second number, therefore 17 minus n will give us 12. Why? Because n here is 5. So that will give us 12 for 17 minus 5. So what does this mean? Therefore, the two numbers are what? 5 and 12. Okay, so that is the answer. Next, how about number 2? Okay. So this is the checking. So indeed, the two numbers are 5 and 12. Now, if we go to number 2, so the problem is, or the given statement is, the difference between two numbers and 6 and their product is 27. So if we are to be asked what are these numbers, of course we will solve the problem. But first we need to represent those unknowns by symbols, and then afterwards we translate in order to formulate the equation. So for our solution, so there are two unknown numbers from this example. So let's just say we use small letter m to represent the first number from this example number 2. And how do we represent the second number? It's m plus 6. So why m plus 6 for the second number? Because the difference of these two numbers must be 6. Okay? Then, for translation, since according to this statement in number 2, the product of the two numbers is 27. Therefore, this number multiplied by this second number will be equated to 27. And the equation goes like this. Ayun. Ayun. M times the quantity m plus 6 equals 27. And just like in number 1, this formulated equation is also a quadratic. Okay? Which can be written in standard form. So m to be multiplied to the expression inside the parenthesis. So that will give us the expression on the left side of the equal sign, which is m times m plus 6 times m. Therefore, the left side expression will become m squared plus 6m, then equated to 27. Now, to make this equation written in standard form, we transpose 27 to the left. And since it is a constant term, it should be written before the equal sign. Now, since we do the transposition, so it means 27 is positive on the right side, and we transpose to the left, it becomes negative 27. So at this point, we have just written this formulated equation to standard form. And this is m squared plus 6m minus 27 equals 0. And from that form, we can solve the equation. Now, since we declare the values of a, b, and c, meaning the method to be used to solve this equation is, I think, using the quadratic formula. Yun. And this is the formula. So you plug in the values of a, b, and c to this expression, which is the right side of the equal sign. So this is the resulting equation. Now, if we want to simplify this expression, we use the GEMDAS rule or the PEMDAS rule. Okay, so this is what will happen. So from the quadratic formula, we split the value into 2. Okay? So we take the negative square root and separate this to the expression which is wherein the positive square root is considered. Okay, so we have two roots. First one is negative 6 minus 12 all over 2, and the other root is negative 6 plus 12 over 2. So that this one right here, when we simplify this, it becomes negative 9. While this expression right here, if we simplify that, it will give us positive 3. Okay? Next, suppose that the first number, m, is equal to negative 9. How do we get the second number? So basically, we refer to this representation to solve for the second number. So using m plus 6, so we plug in m here. So we know that m is negative 9. So negative 9 plus 6 will give us negative 3. Okay? Therefore, the two numbers are negative 9 and negative 3. But what if we consider the other root as our first number? And that is 3. Tama? So let's just say if the value of m is 3. How do we get the second number? Again, using the same expression, m plus 6. But this time, m is 3. And that will give us 9. Again, this is 3 plus 6 is 9. So what does this mean? We have two possible pairs of numbers. The first pair of two numbers are both positive, 3 and 9. Or it could be the pair of numbers are both negative. And these are negative 3 and negative 9. Okay? So this is the answer. Next. So this is the checking. So therefore, the two numbers are either 3 and 9 or negative 3 and negative 9. Okay. Again, 3 and 9 or negative 3 and negative 9. Next. Okay, so these are the answers for number 2. How about number 3? Okay, the sum of two numbers is 14 and the product of their squares is 100. Of course, there are two unknown numbers and we need to represent them by symbols. So let's just say the first number is denoted by small letter r. Now, how do we get the representation for the second number? That is 14 minus r for the second number. And why is it 14 minus r? Since in number 3, it is stated that the sum of those numbers is 14. Ayun. Okay? Then upon representation of the unknowns, we go now to the formulation of the equation, but not yet. Okay? Since there is a condition stating that the sum of the squares of the two numbers is 100. So it means we square each of these numbers. So for the first number, we square that will give us r squared. And for the second number, we also get its square. So that is actually quantity 14 minus r squared. Okay. Then, for our translation, since the sum of the squares of these numbers is 100, meaning r squared is to be added by this quantity squared. And the equivalent is 100. So, for our equation, we have r squared plus quantity 14 minus r squared equals 100. And this one is quadratic, so we can rewrite this to standard form. How? Okay, so we expand this binomial, square of the binomial, and this is the result. A perfect square trinomial. Then we bring down r squared together with equal to 100. Okay? Then we combine similar terms. So r squared plus r squared is what? 2r squared. Yun. Then minus 28 because after the quadratic term, linear term should be written first. And what do we do with the constant terms? Now, 96 should be written as the third term. But wait, there is another constant term on the right, which is 100. So we need to combine these two, or 100 transposed to the left, so that it becomes minus 100. Okay, or 100 to be subtracted from 196, and that will give us 96. So at this moment, we have this quadratic equation, and we cannot totally tell that this is the simplest quadratic equation in standard form, because you will notice that each term can be divided exactly by 2, including 0. So if we're going to make the quadratic equation like this, written in a simplest form, so we simply divide again each term by 2. So the resulting quadratic equation from this form will be like this. R squared minus 14r plus 48 equals 0. And from this standard form, we can solve that equation by factoring. Since this expression is factorable, and the factored form is quantity r minus 8 times quantity r minus 6 equated to 0. Upon getting the factored form, each factor is then equated to 0, applying the zero product property. And because of this, we have two resulting linear equations. So for the first equation, what is r? It's 8. And on the second equation, what is r? Is 6. Now, what if r equals 8? How do we get the second number? So again, using this expression right here, 14 minus r. And we know that r is what? 8. So 14 minus 8 will give us 6. So at this point, we can say that the two numbers are 8 and 6. 6. But wait, what if r is 6? So we have two cases. No? This time we now go to the second case where r is equal to 6. So if this is the first number, what is the value of the second number? Again, we go to the expression 14 minus r, plug in the value of r, as we all know that is 6 from here. So 14 minus 6 is equal to 8. So what is our conclusion about the third problem? Okay, the two numbers are therefore 6 and 8. Okay? So that is our answer. So if we do the checking, we can do that. So that is 6 plus 8. Indeed, the sum is 14. So if we get the sum of their squares, therefore we get the square of 6, that is 36. For 8, its square is 64. So we get the sum of their squares, so that will give us 100. So indeed, the answers, the two numbers are 6 and 8. Or we could interchange their position. It's still the same. Therefore, the two numbers are 8 and 6. Okay? For our next slide, to sum up what we did on those examples from the previous slide, okay, we have these four suggested steps in solving word problems like number problems. Okay. For our first step is this: read the problem until it is fully understood by representing a variable or any symbol for the quantity involved. Second step, which is letter B, using that variable or symbol to translate the conditions stated in the problem to form a mathematical statement or equation. Third, or C, and from the formulated equation, solve it using any appropriate method of solving quadratic equations. Now, what are these methods? It could be extracting square root, factoring, completing the square, or quadratic formula. And the last step is, upon solving the equation, we check the result or the obtained values of the unknown against the given condition or formulated equation. Okay? Okay, so I think we're done with the discussion about number problems. So this time we now go to the next type of problems. And this time I'm going to discuss about the rectangular dimensions problems. Now, how do we solve these type of problems? Now, let us consider the following examples. Let's just say for our first word problem under this type. Okay, how do we solve this first example? The length of a rectangle is 10 units more than its width, and the area is 600 square units. Find its dimensions. So, if we are asked to find the dimensions, the problem is referring to what? The length and the width of the rectangle. So, those are the unknown dimensions. So, the first part of solving this problem is to make a representation, particularly representing those unknowns by symbols. So let's just say we use the small letter W as our symbol to represent the width of the rectangle. And for the length, the representation is W plus 10, since according to the problem, the length is 10 units more than its width, or 10 units longer than its width. Okay? Then, on that problem, it is stated that the area of the rectangle is 600. Okay? Ayun. So, the length is labeled as W plus 10, while the width is labeled as W. Now, translation. Since the area of the rectangle is 600 square units, we have this formulation of the equation, or the translation. Okay. Area of a rectangle, as we all know in your elementary mathematics, is the product of length and width. Therefore, substituting the value for the area of the rectangle, so that is 600, equals the length, which is represented by this expression W plus 10, times the width, which is W. And at this point, you will notice that the formulated equation is actually a quadratic. And if it is quadratic, we can rewrite this to standard form. Yun. Okay, so we use the symmetric property. We just simply interchange the position of the left and the right side of the equation. And this is now the equation. So if we're going to simplify the left side expression, okay, so we have, okay, W squared. How did we get W squared? That is actually W times W plus 10 times W, so 10W equals 600, and we transpose 600 to the left, and at that point we have just written the equation to standard form. W squared plus 10W minus 600 equals 0. And from this quadratic equation, we can solve this by any method that you already know. So in this case, what method? We use factoring, because this expression right here is factorable. And the factored form is what? Quantity W plus 30 times W minus 20 quantity. And again, applying the zero product property, we equate each factor to 0. So for our first equation, that is W plus 30 equals 0, while the second equation is taken from the second factor, and that is W minus 20 equals 0. Now, solving each resulting equation, the first one is W equals negative 30, and the second equation, we have W equals 20. Now, if W is 20, then we could get the length of this rectangle, which is W plus 10. So we plug in 20 as the value of W. So this is 20 plus 10 is 30. Now look. Hence the length and the width of a rectangle are what? 30 and 20 units respectively. Meaning yung 30 na unang binanggit ay sa length at yung pangalawang binanggit naman ay sa width. Yun ang ibig sabihin ng salitang respectively. Now, by checking, so if these are the dimensions, of, if we're going to multiply them, the area is 600. So it's checked. Now, take note, why we did not consider the value of negative 30 as the measure for the width. Okay, we cannot consider this value since there is no such thing as negative dimension for either width or length. So indeed, these are the answers. These are the dimensions. Next. For example number 2, an 8 cm by 10 cm family picture is in the frame surrounded by a border of uniform width. The combined area of the picture and the frame is 168 square centimeters, as shown below. Find the width of the border. Okay. So for the unknown quantity, we let small letter w be the width of the border. Now, referring to the figure, and use area of the rectangle equals the product of the length and the width. So we need the figure, and this is the figure. Now, let's just say this rectangle right here is actually a picture, a family picture. And this family picture is to be placed on a frame. It should be placed in a frame with a uniform width. Okay, so ito yon. So nilagyan natin ng border yung picture. Okay, yan. So this is the frame with uniform width. Now, from the figure, okay, the dimensions of the picture is 8 centimeter by 10 centimeters. And again, it is to be bordered with the uniform width represented by small letter W. Now, for the combined area of the rectangle in the frame, we have what? The area of the outer rectangle is equal to the product of the length and the width. Ito yun. This is the length, that is 2W plus 10 times the width, which is 2W plus 8. Now, and the combined area is 168. Okay. Then changing this equation to standard form, we have what? Okay, since we factor out 2 factors of 2, so 168 has 2 factors of 2, or actually, the common factor on both sides is 4, and that is 2 times 2. So we drop 2 times 2 on both sides, and what will remain from the equation is what? Quantity W plus 5 times quantity W plus 4 equals 42. Then, of course, we use the FOIL method to get the product of the expression, the product of 2 binomial factors on the left side. And this is the product. Then, transpose 42 to the left. So, the last two terms will have 20 minus 42, and that is negative 22. So, therefore, this is now the standard form. And I think this is also factorable. The expression on this side is factorable. So, what is the factored form? It's, okay. So, solving this equation, we did not use factoring, but a quadratic formula. So, we declare the values of A, B, and C, and these are 1, 9, and negative 22. Now, solving the equation, say by quadratic formula, and this is the formula, so we plug in the values of A, B, and C to this expression. And the resulting expression would be like this. Then, applying the PEMDAS rule to simplify the right side, we have actually 2 values. Yun. We're going to simplify this. We have this form. Negative 9 plus or minus 13 all over 2. So, we split the 2 values. We take the negative square root result and separate it from the positive square root result. Yun. So, negative 9 minus 13 all over 2, while the other root is negative 9 plus 13 all over 2. And what do we get? So, the width is negative 11, while the other width is 2. So, basically, we cannot accept this. Because when we talk about dimensions, the measures are always positive. And the only positive value that we have here is the value of W, which is 2. So I guess this is what we're looking for. Therefore, the width of the border is 2 centimeters. Okay? Next. If you don't have questions, so the answer to this problem is the width of the border is 2 centimeters. Okay? Next. Of course, we do the checking like this. And for our next problem, a farmer has a rectangular garden plot surrounded by 90 meters of fence. The area of the garden is 350 square meters. So, given 90 meters of fence surrounds the garden is actually the perimeter. And let's just say P represents the perimeter. Oh, no, not necessarily. We represent small letter P as the width of the rectangle. And L be the length. Okay, so ito yun, no? Of course, the longer side is the length and P is the width. And the area of the garden plot is 350 meters squared. So, using the formula for the perimeter of a rectangle, that is twice the length plus twice the width. And substituting the value, according to the problem, the perimeter is 90 meters. Then 2L plus 2P. And we divide all terms by 2 since 2 is common. So the equation becomes simpler. So that is 45 equals L plus P, or L plus P equals 45. Then, solving for the length L in terms of P. So therefore, this equation becomes what? L equals 45 minus P. Then what else? Yun. Translate the area of the rectangular garden. Okay. Translation. The area of the rectangular garden is 350 square meters. Therefore, using the area formula, which is length times width, we have this equation. Area replaced by 350 equals L times P. But we know L is what? 45 minus P. So this value right here is to be replaced by this quantity right here is to be replaced to L, or to be plugged into L. So the equation becomes what? Quantity 45 minus P times P equals 350. And this is the quadratic equation, which is not written in standard form. So if we're going to rewrite the equation in standard form, it goes like this. Okay, 45P minus P squared equals 350. Then, those terms on the left is to be transposed to the right, to the right, yes. So that the equation on the left side will become P squared minus 45P plus 350. And by symmetric property, P squared minus 45P plus 350 equals 0. And from that point, this quadratic equation in standard form can be solved by factoring, since this expression is factorable. So, the factored form would be what? Quantity P minus 10 times quantity P minus 35, which is equal to 0. So, equate each factor to 0. The first one is P minus 10 equals 0, and the other equation is P minus 35 equals 0. Now, solving each resulting equation, the first root is 10, the first value of P is 10, and the second value of P is 35. So, what does this mean? Now, since P represents the width of the rectangle, we can only choose the value 10 and not this one, 10 meters. Okay? So that is the width. So that the length in L equals 45 minus P. So we just plug in P here by 10. So the expression on this side will become 45 minus 10, and that is the length of the rectangle. Yun, 35 meters. Okay? So by checking, quantity 45 minus P times P is equal to 350. Of course, the value of P is to be replaced, right? So it's 10. 45 minus 10 is 35 times 10. So it's 350. So our answer is correct. Okay? Yeah. And at this point, I have just finished discussing the first two types of problem. And we'll see you next time.